Okay, now we're into Chapter 6, Lesson 3. We're going to be solving systems of equation by using elimination. So if you remember back in Lesson 1, we did solving systems of equation by graphing. And where the lines intercept, the ordered pair was our solution to the system of equations. And then in Lesson 2, we used substitution, where we solved for either x or y, or we isolated x or y, and then we plugged it in to one of the values, and then our main goal there was to get one of the variables alone. Okay, we wanted to eliminate one of them. So this is again what we're doing here, but in a different way. So elimination means that I want to cancel out an x or the y. It doesn't matter which one. The nice thing about this process is that I get to choose if I want to eliminate the x variable or if I want to eliminate the y variable. So I want to set it up similar to an addition problem so that I can cancel out one or the other, so that when I get the x, only an x in an equation or only a y in an equation, I can solve for that value. So our first example here, I have two equations. The x is minus 2y equals negative 19, and 5x plus 2y equals 1. So I get to choose which variable would be easiest for me to eliminate. And again, it does not matter if I eliminate the x or if I eliminate the y. Okay? But in this one, I can see clearly which one is going to be the easiest for me to do. If I set this up as an addition problem, I have a negative 2y and I have a positive 2y. So that would be the best route for me to go. So if I rewrite this first equation as x minus 2y equals negative 19, and I set it up like an addition problem, like I said, and 5x plus 2y equals 1, I can clearly see that I can cross out the two y's. Okay, so but let's just go in order. So I have x plus 5x, that's going to give me 6x. Negative 2y plus 2y cancels out, leaving me with negative 19 plus 1 is negative 18. Okay, so now the x is being multiplied by 6. I need to undo that, and I'm going to divide by 6. Giving me the value, since I've isolated just the x, now I can clearly see that the value of that x is negative, because my negative and my positive make a negative, and 18 divided by 6 is 3. So far in my ordered pair, I have negative 3 for my value of x. Now I have to find the value of y. I can do that by going back into either of the original equations, it does not matter which one, and plugging in the value of x to solve for y. So I'm just going to take the very first one. So I have x is negative 3 minus 2y equals negative 19. Now, I know that I have to move that 3. I have to do my addition or subtraction first. So since this is a negative 3, I'm going to add 3 to both sides. Okay? Again, those cancel out, leaving me with my negative 2y, and negative 19 plus 3 will give me my negative 16. And then finally, we have negative 2 being multiplied by the y, so I'm going to divide, leaving me with my value. Those two will cancel out. Y equaling my negative, and my negative is going to make a positive, so be careful there. And 16 divided by 2 is 8. So my value of y is 8. And I can go back and check. I'll do a real quick one equation check just to save time. But I can say that x is negative 3 minus 2 times my value of y is 8 equals negative 19. So if I do negative 3, negative 2 times 8 is negative 16 equals negative 19, and negative 3 minus 16 is negative 19 equals negative 19. So I know that that system checks. And again, you should follow through and check both equations to make sure that they are true. I am going to skip it just to save a little bit of video time. Okay, so let's move on to another example that you might get. Okay, so let's suppose that you are given an equation that is, let's set this up so that you can see it, 3x plus 4y equals equals 18. And negative 2x plus 4y equals 8. Okay? So again, I get to pick and choose. I can eliminate the x variable or I can eliminate the y variable. And remember, I should have said this at the beginning of the video. When you are doing elimination, you should have it set up in the standard form. You should have your variables lined up. So it should be in the form of ax plus by equals c format. You want to get the variables lined up so that you can see what can be eliminated. Okay? So get the variables stacked so you can determine what you want to do. And then from that point, it's your choice of what you want to eliminate. So when I'm looking at my two equations here, my eyes go directly to the 4y's. But if I add them, I'm going to get 8y. I don't want to get 8y. I want to eliminate my y. So that one of these needs to be a negative 4y. And it doesn't matter which one. But what I have to do is to get it to be a negative 4. One of those has to be a negative 4. So I'm going to rewrite my equation. And again, it does not matter which one. So I'm going to take my top equation and leave it alone. My second equation, though, is I'm going to take it and I'm going to multiply that whole equation by, I don't want to change the digits. And we know any number times 1 will keep that digit. So I'm definitely going to multiply it by a 1. But I want to change the sign of that. I want to make it a negative 4. So I'm going to multiply the whole equation by a negative 1 instead. Okay? So by doing this, I can rewrite this bottom equation as negative times a negative will make a positive 2x. A negative times a positive will give me my negative 4y. And a negative times a positive will give me a negative 8. Okay? Now I am set up to where I can add these equations together. So this is no longer the equation that I have. This is the new one rewritten. So I have 3x plus 2y will give me 5x. I said that wrong. 3x plus 2x is 5x. My positive 4y and my new negative 4y will cancel each other out. So I eliminated the y, leaving me with 18 minus 8, which gives me 10. And then I'm going to divide both sides by 5 to eliminate this 5 with the x, so that those two will cancel out, leaving me with x equals 10 divided by 5 is 2. So in my ordered pair, I have the 2. Now I need to find the y. So I can do that again by going up to either one of these original equations and plugging in the value of x to now solve for my y. I don't need to rewrite anything. I just pick one of these equations. So again, I'm just going to make it simple and go to the top equation. So it's 3 times x. Well, now I know what x is. It's 2. Plus 4y equals 18. Now I'm going to solve for the value of y. So we have 3 times 2 is 6, plus 4y equals 18. All right, reversing the order of operations, I'm going to do my adding and subtracting first. So I'm going to subtract 6 from both sides, leaving me with just 4y equals 18 minus that 6 is 12. Okay, then I am going to divide both sides by that 4. Why? Because I want to isolate that y. Leaving me now with y equals 12 divided by 4 is 3. So this value goes up into my ordered pair. Remember, we have to write them as an ordered pair, and this is our solution. How do I know if I did it right? By going back to my original equations and substituting the value for x and y into our equations and seeing if it equals what we claim it should equal. And that's how we check our work. I highly recommend that you check your work. Let's try another example. What if I'm giving the situation of 2x plus y equals 3 and negative x plus 3y equals negative 12? Okay, so in this situation, there's no common coefficients here. So again, I get to choose what equation I want to, in my own words, manipulate so that I can cancel out either the x or the y. So I can either make this a negative 2x, or I can make this a positive 3y by multiplying the whole equation by the digit that would help me do that. So I am going to opt to make this a negative 2x. So I'm going to rewrite my top equation. So I have 2x plus y equals 3. I'm going to take my second equation, my negative x plus 3y equals negative 12, and I'm going to multiply that whole thing by what? What am I going to multiply it by? A positive 2, right? So remember, I have to distribute that 2 to every term inside that entire equation. And again, I want to back up and make sure that you notice too, they are lined up in standard form. The x plus y plus c. Okay? So now when I distribute this 2, I'm going to have negative 2x. My positive it still makes it positive, and I have a positive 6y. And then my 2 times my negative 12 is going to give me a negative 24. Okay? So this equation is no longer there. So now I'm going to treat it as if it is an addition problem. So I have 2x minus 2x. Well, that's 0, right? So those are the two that canceled each other out. Leaving me with y plus 6y gives me 7y. I have 3 minus 24. That's going to give me a negative 21. And I'm going to divide both sides by that 7, giving me my value of y equals negative and a positive makes it negative 3. So now I can take my value of y, go back up to one or the other original equations, and solve for x. So I'm going to take this top equation, and I'm going to say 2 times x, I'm solving for x, plus y, which is negative 3, equals 3. Okay, so I have 2x. I had an extra step there I didn't need to do, but let's follow through and do it anyway. My positive and my negative is going to make a negative 3 equals 3. All right, and then I have to add or subtract first. So in this case, they're subtracting. I'm going to add, leaving me with 2x equals 6. Divide both sides by 2, leaving me with the value of x equals 3. Okay, so my solution, I keep wanting to call it ordered pair. It's one in the same, but in this case we like to call it the solution. Is 3, negative 3. And again, all of this says is if I get this into the y-intercept form, if I graph this, if I graph these two equations, but I have to get them into my graphing format, where these two lines will intersect should be at 3 and negative 3. And again, you can go back and plug these values into your equations to check your work. Let's see if there's any other major examples I have to show you. I think that is it. So that is how we do elimination. So let's sum up what we said. You are choosing to eliminate either your x or y values after you have them set up in standard form. So you're lining your variables up first. Eliminate the x or y, totally up to you. And you can manipulate, those are my words, one of the equations so that we can cancel one or the other out. In other words, our whole goal is to get the variable, you're going to get either the x or the y variable alone so that you can solve for it, and then take the value of that variable that you just solved for and plug it back into one of the original equations to find the value of the opposite variable that you did not solve for. Okay, so again, that's 6-3 in your packet. Let me know if you have any further questions. I will talk to you guys soon. Good luck. Bye.